All right, guys, since there's no note page, I need you to be paying extra close attention, potentially watching this twice to make sure that you're accountable for the information. So I wanted to spend some time talking about why we would need common denominators and then kind of think about it pictorially and talk only a little bit about how to find them. Okay, so this is just more so of a preview. So why would we need common denominators? For a couple reasons. One reason is so that we can make fractions a little bit easier to compare when we're thinking about which fraction is bigger or smaller, or when we're putting fractions in order from least to greatest or greatest to least. Having denominators that are the same, meaning the pieces that a whole is cut into are uniform, then that makes it a lot easier to work with. It's very easy, as you can see, to compare 1, 2, 3/4 with just 1/4. It's the quantity you're comparing them, okay? So 3/4 with 1/4 is a whole lot like comparing 3 and 1. It's clear to see that 3/4 is the bigger quantity. It's the larger quantity. When you're thinking about 5/12, you can think about it like this. And we're comparing 5/12 with 2/12, the quantity of 12ths that we have, the amount of 12ths we have. So when we have that same denominator, we already have the pieces in the same size, so we can focus on how many pieces there are. And it's clear to see that 5/12 is bigger. So when you're comparing fractions, having common denominators makes it much easier. So think about it like this, if you're not convinced yet. These two fractions, 2/11ths and 1/5, I put them right next to each other. This is a fifth. 1 out of 1, 2, 3, 4, 5 parts is shaded. And this is 2 out of 11 parts. When you're comparing these, it's quite difficult to see which one is bigger with the picture. You have to make sure that you're being accurate. So you would need to make sure that 2/11ths and 1/5 would be changed so that they would have the same denominator and therefore the same amount of pieces so that we could compare more easily. Another reason you would want to have common denominators is they're needed. You cannot go without common denominators when you're adding and subtracting fractional quantities. So you can see here we're adding 2/4 plus 2/4 for a total of 4/4 or 1. Okay? And subtracting, we start with 3/8, we get rid of one of the eighths, and we're left with 2/8. It's very simple, okay? But when we come to something like this, when we're adding 1/6 and 2/5, how are we supposed to represent our answer? Okay, how can we represent these together when they're different sizes, when the denominator is different? We can't go any further than that because we need them to be the same size. Sometimes you can think about it like comparing apples and oranges. When you're adding 1/6 plus 2/5, because those denominators are different, it's like you're adding apples and oranges. There's 5 of something, but what could we call it? We would have to change the denominator. We could call it fruit and get away with it, but that is a completely different unit than the original, right? Completely different unit. So we need to change the denominator to make sure that we can compare, add, and subtract. So I wanted to show you this quick video with an old friend. You probably remember watching that Dawn of Numbers video, so the voice should sound familiar. But pay close attention because the pictures he shows are very helpful.
Let's say that we want to add the fraction 1/3 and 1/2. We can use the number line to visualize this. Since the fraction 1/3 has a denominator of 3, each unit length on the number line is divided into 3 equal divisions. And the fraction 1/3 is represented by one of these divisions. On the other hand, the fraction 1/2 has a denominator of 2. So each unit length on the number line is divided into 2 equal divisions. And the fraction 1/2 is represented by one of these divisions. Unfortunately, when we add these two fractions, the sum won't fit into either set of divisions. This is true whether we use 3 divisions per unit or 2 divisions per unit. Since each fraction is expressed using different size divisions, it's like trying to add apples and watermelons. The solution is to create new divisions which will work for both fractions. We need to divide the unit length in such a way that each fraction will fit perfectly into these new divisions. If we do this, then both fractions can be represented by some number of these new divisions. Since both fractions will then use the same size divisions, they will have the same denominator. In other words, they will have a common denominator. We can then simply add their numerators. For instance, in this example, we can split each division on the top number line in half. Each unit length on the top line will then be divided into 6 equal pieces, and the fraction 1/3 will be represented by 2 of these divisions, or 2/6. Now if we split each unit on the bottom number line into thirds, each unit on the bottom line will also be divided into 6 equal pieces. The fraction 1/2 will be represented by 3 of these divisions, or 3/6. Both fractions now represent some number of the same size divisions. So now we can add their numerators. And we see that these two fractions add up to 5/6. So when adding or subtracting fractions with different denominators, we must find a single denominator which will work for all of the fractions. In other words, we must find a common denominator. So,
all right, I'm going to take over now, guys. So that number line showed you very clearly that the sizes of the parts must be the same in order to perform operations on the fractions. So going back to what we did when we were studying factors and multiples, you probably remember this statement in red. A number can fit evenly into its multiples. For example, 3 can fit evenly into 3. 3 can fit evenly into 6. 3 can fit evenly into 9, and so forth. Okay, so at the same time, when we're thinking about common denominators, we are looking for a number into which both denominators can fit evenly. Okay, so both denominators must be able to fit evenly. So let's say we're taking a look at 1/3 plus, let's say 1/4. Okay, both of these denominators must be able to fit into a number evenly in order for us to make that amount of divisions on our number line. You can think of it that way. So some of 4's multiples, 4, 8, well, we have to actually take this one a little bit further. There we go. 4, 8, 12. And you can see that the number into which 3 can fit and 4 can fit evenly is the number that will change into their common denominator. Okay, and so the key here is that in order to keep these fractions simple, because I mean they could fit into a lot of other things. 24 is something they can both fit into too, but that number is bigger, and we want to keep it simple. We want to keep it simple. So this is their least common multiple between 3 and 4, and so that will be the new common denominator because both 3 can fit into it and 4 can fit into it. Just like in this video, when we go back a little bit, we see that they changed the amount of divisions between 0 and 1 into 6 divisions because the original divisions, 3 can fit into 6, and the original divisions down here, 2 can fit into 6. So 6 was their least common multiple, and so that many divisions can hold either fraction evenly. So when I'm thinking about this, I need you guys to get on my same level in terms of language. When we are changing denominators so that we can either compare two fractions, add two fractions, or subtract two fractions, I refer to them as different levels. So this is very important that we be able to communicate with each other like this. So level 1 fractions, like the ones you see, 2/3 and 1/3, They're level 1 because they're the same. The denominators are the same, and we do not need to act upon this at all. We do not need to change the denominators because right now, looking at this, we can only deal with the numerators. 2/3 and 1/3, it's just like those pictures. There's more thirds here than there is here, okay? 2 is more than 1. So 2/3 is more than 1/3. So level 1 is when the denominators are the same, so we keep them the same. We're in good shape, okay? Level 2 is when we see, let's take a look at these two fractions. Let's say we are asked to either compare or add, whatever, 3/4 and 3/8. Right away, you should see that these are not level 1 fractions because these denominators are not the same. These denominators are different, okay? But you should also notice that the smaller denominator, 4, can fit into the larger denominator. So the larger denominator is a multiple of the smaller one, or the smaller one is a factor of the larger one, whichever way you want to think about it. But in this case, when you're changing when you're making them to be common denominators, the common denominators here, their least common multiple would be 8, because 8 fits into 8 and 4 fits into 8. Okay, so those are easier. Similar ones would look like 4 and 16, because 4 can fit into 16. Similarly, we would have 3 and 9, because 3 could fit into 9. Those are instances where they're level 2 because one can fit into the other. So all we have to do is change our denominators to the bigger of the two, because we know that every number, its first multiple is itself. So that makes sense for us. Level 2 is the second level in changing denominators. The last level is when, well, let's take a look. It's definitely not level 1. The denominators are different, okay? So we need to make the denominators the same before we can compare them, before we can order them, before we can add or subtract them. And so when we are changing them, we have to decide, is this level 2? Can the smaller one fit into the larger one, okay? Or we can think about it like being, is the smaller one a factor of the larger? Or is the larger a multiple? Well, no, 10 is not a multiple of 8. 8 cannot fit into 10. So, to find the common multiple here, the least common denominator, we're going to need to find the LCM. And the LCM between 8 and 10, it's not 80. 8, 16, 24, 32, 40. And then you should automatically see, oh, hey, that ends in 0. And so, being that that's the first multiple of 8 that ends in 0, we know that that's also a multiple of 10. So, the least common multiple here is 40. 40 is the least common multiple. It's level 3 because 8 doesn't fit into 10. They don't fit into each other evenly, so it's a third option of having to look at all of the multiples. So this is very important that you have this language when you're thinking about common denominators. Let's look at a couple of practice problems. So the two examples I gave you, 2/3 and 1/4, I'm not asking you to change the fractions. I'm just asking you to tell me what is the common denominator. And I want you to also reflect on what the level might be. Okay, so I'm looking at 3 and 4. In this one there's 3 divisions, and in this fraction there's 4 divisions. What would be a number into which both 4 and 3 could fit? Well, let's go through the levels. This is not level 1 because they are not the same denominator. And it's not level 2 because 3 is not a factor of 4. So it has to be level 3, meaning that we have to find the LCM on our own. Okay, and then the LCM of these two numbers would be 12. And therefore these would be, 12 would be the common denominator. Okay, let's also look at the one to the side here. Let's look at what would be the common denominator, a number that we could assign as our new division so that they could be split up 4/5 and 6/7 could be split up into equal parts in